Greetings and welcome to the ECE lecture. I'll manage to screw up the announcements and everything, but my job, I'm Dave Farber, my job is to introduce the speaker. So I'll try to make it short. I've known Guru now for many, many years. I was his advisor at the University of Delaware for his PhD and have kept in touch with him over the years. Guru's had a long and distinguished career. I'll let you read the details from the program. I'm not going to spend time there. I'll just point out that he's been in a number of interesting aspects of the field, everything from being an entrepreneur, founding several companies that have done well, was a venture capitalist for a while, an academic for a while at Washington University in St. Louis, and currently is both I forget what the exact, consulting professor at Stanford and runs several of the interesting labs at Stanford, OpenFlow and others. He's done spectacular work and we should be proud of him. And with that, I'm going to introduce Guru to talk.
So thank you, Dave, really appreciate it, and thanks the department for inviting me for this special occasion. I'm really, really grateful. As Dave mentioned, I got my PhD here in '87. So I was here from '83 to '87 and I have very, very fond memories of the campus, the experience and all of that. And over the years I've come here multiple times and always very grateful for what the university and the department did in my life. I mean, it shaped my professional life, shaped my personal life, and I still distinctly remember that my memory of the department compared to what I hear stories about other departments, this department was known for very gentle, caring, and very supportive. Believe it or not, when I came here, I couldn't speak well, I couldn't write well, I was kind of, very raw. And then people like Dave and others and all these people took me and groomed me and really made a huge difference in my professional life. So of course, I thought I will thank few people more specifically. Dave, of course, as my not only as an advisor, he has stayed as an inspiration. We have stayed in touch as a guide and all of that for all these years. It is, over 30 years or more. Then there are two other gentlemen from computer science department, Adarsh Sethi. I thought he was here in the audience. I thought him coming in. And then Paul Amer, I just found out that Paul retired. Both of them faculty members. They also played a very important role in helping me finish my PhD thesis. Adarsh helped me on the performance side of my thesis. Dave was never big on performance, and in a PhD thesis you have to have a performance aspect of it. So Adarsh was kind of my second advisor who helped me. And then in my thesis there was something about protocols. And again, Dave was never big on formal specification, though he has done some very good work in that area. And so Paul kind of helped me with the specification. So it's also an indication of how collaborative the community at least was then. I can't comment now, but I'm sure it has continued. But as a PhD student, I could lean on multiple people and get advice and help. And then there were a couple of other people who were in networking at the time, faculty members, Dave Mills and Tanjay Sedam. And if you take a minute that this is 83 to 87 when internet was just starting, and this was a unique university where there are 5 professors who were doing research in networking. I can't name any other university in that time frame when they had such a strong networking group that covered different aspects of networking. And so I was very fortunate to benefit from all of this, and I am grateful for the same as well. And there are of course many others who helped in this particular my journey. So thank you again and really appreciate it. Okay, so now I'm going to talk about this particular topic. This is, the title is Internet Infrastructure Transformation. So really the networking industry is going through a major change or a transformation, and again I'm fortunate that I'm part of it, and I will just share that journey with you. This is less of a research talk. When I was talking to Ken, Ken said for this particular occasion, rather than doing a very focused research talk, if I gave a little bit higher level what's happening in the industry, that may be better. And so I've decided to focus on, bigger trends and what that means. Okay? So with that, let me get started. I should mention that right now I'm spending most of my time at this organization called Open Networking Foundation, which came out of Stanford. But all this work that I'm going to talk about started at Stanford and Berkeley, and then has moved into this organization and across the industry. Okay. So let me take you back a few years in the time frame of 2003-2007 time frame. If you go and look at networking literature of that time frame, you will see number of papers written in that time frame when the research community started to say internet is ossified. It's not evolving fast enough. We as the research community is not able to have an impact. So there were number of papers written about it in that time frame, and it almost seemed in that time frame that networking is kind of now a mature discipline, and we are kind of coming to an end, and maybe researchers should be doing something else with their lives rather than focusing on networking. But still, to kind of stimulate it, there were a number of research programs that National Science Foundation and other foundations in other countries launched to kind of stimulate networking research. Okay? So that was then. Now let me tell you another story from story or an observation that started to become evident around 2005-2007 time frame. If you went and talked to any one of these service providers, AT&T, Verizon, Deutsche Telekom, Comcast, they were observing this particular pattern, and that pattern is that the traffic growth was very high, 50-60% a year. So because of the smartphones, video, YouTube, all of that, the traffic was growing very quickly. And the cost of running the network was also kind of proportionately growing with the traffic growth. Not the same, but little bit slower. However, the revenues were either flat or dropping, because if you think about a common family in US or anywhere else, we continue to pay $40, $50 a month, and even though we are consuming 10 times or 100 times more bandwidth from the network, we are paying essentially the same amount of money that we paid maybe 10 years ago, right? And so if I'm a network operator like AT&T and Verizon, as they say, you don't need an MBA to figure out that you will go out of business if you continue to operate this way. Your costs are going exponentially, revenue is flat, sooner or later you are going to go out of business. So these two trends, when researchers wanted to do something and the network operators were saying that, hey, I cannot continue to build my network the way I have been building for last 10 years or 15 years, because if I keep doing it, I will go out of business. So now the question is, you ask, why is it that the network operators were having this problem of cost going and not keeping up with the traffic, and why are the research community was not able to make changes or evolve? So we did a lot of research, and the rest of the research community did a lot of research, but at Stanford we kind of had an observation. And it was a very pragmatic observation. It is not a science, it's not rocket science. But the observation was that the internet was built with boxes that look like this. And they are closed and proprietary and vertically integrated. If you look inside any one of these boxes, what you will see essentially is there is ASICs that are custom ASICs that are built by Cisco, Juniper, Ericsson, Nokia, whoever they are. On top of that, they build their own so-called router operating system, again customized, built by a particular vendor, and then on top of that there are a number of features, and the features are routing management, mobility management, access control, VPN, and all of that things that you know and learn in networking. Now, another thing is this software stack that people were writing, they were bloating and bloating. It was like many millions of lines of code. And another thing is that the network community was not stopping standardizing. The number of standards we were creating were at amazing rate. I mean, this number is old, I think it must be over 7,000 now, I don't keep track of it. And every time you needed a little feature, you standardize it. And then you would think standards are good for you, right? Because there is a very positive connotation about standard. But if you look at the networking industry and how it was doing standardization, it was doing it in such a way that the vendors could still add proprietary stuff, and the two boxes, one from say Cisco and another one from Juniper, hardly ever interoperated. So you build islands, so you build one island with Cisco, another island with Juniper, and then at the interoperability you may have BGP or something that they will figure out how to interoperate. But other than that, you have to keep building these islands, and that is still true, by the way. That is what is happening in the networking industry even today. Billions of gates, bloated, power hungry. So when you look at, if you build a network infrastructure with boxes like this that are closed, proprietary, with this kind of thing, you can imagine a grad student who wanted to come up with a great idea and wanted to prove it out. It's almost impossible. You can prove it in your lab, but what do you do beyond that? Inserting your idea into a box like this is almost impossible unless you work for one of the vendors. If you are a network operator, AT&T, Verizon, whoever, or even University of Delaware as a network operator, Dan is here, so, right. So what do you do? If you wanted a new feature, you wanted some customization of your network, what do? You go to the vendor and you tell the vendor that, hey, I want this feature. What would the vendor do? He'll say, okay, here are all the requests coming in from different customers. Who is going to pay me the most, right? And then decide how to prioritize. And if you are lucky, after 6 months or a year, that feature will show up, and then you are able to use that particular feature. And you know, if I'm a network operator, I'm AT&T, I spend $20 billion a year on network infrastructure. I spend $20 billion a year and I want a change in my network. What do? I go to my vendor and beg that I want this feature, and 6 months later that feature shows up. Okay? So that is how we used to operate or still operate our network, and you can imagine this is not good for networking, this is not good for network operators, it's not good for research. Okay? So there was this idea, you know, whatever 10 years ago now, more than 10 years ago, it was later MIT, whatever the tech review, they named the idea software defined networking. When we started this work, we were not even calling it software defined networking. They named it software defined networking, and that name has stayed on. But here was the basic idea. If you still look at control forwarding, the idea was, what if you could lift, you can separate that forwarding, that forwards packets from one place to another, and lift that control out of it, and then create something like a control plane. And then what that control plane can do is create what we call the global network view. That global network view is essentially the entire state of the network that is available to you at one location. You can think of it as in a memory or in a data store somewhere. So you know the state of the network, and then you can write control programs to manage this network, and then you can decide. So you operate on the global network view. If you want a new routing, you want new traffic engineering, you want new kind of VPN, you can do that kind of stuff on that thing, and the control plane will take all those functions and program the packet forwarding devices, and then that is how you can do it. So if you could do that, then the idea is that control plane and all of that, that could come from anywhere. The forwarding can come from one vendor, the control plane software can come from another vendor, and as long as you have open interfaces, then on top of that you can write those control programs. If I'm AT&T, I want to change the behavior of my network. What do? I write a control program. Either I can write it, or I can go to a third party and say, hey, can you write this control program that can change the behavior of the network, and I can get it. I don't have to go to the vendor and get it. If I am a researcher as a grad student and I come up with a new way of doing mobility management, what do? I write that control program, which is very easy to write, right? Try it out, and then you have this. Okay? So, another way to look at this is packet forwarding. That control program these days is called network operating system, which is logically centralized, and then on top of that you can do routing, traffic engineering, mobility management, you name it, and all these things now people have done on top of that network operating system, and it becomes much easier to do. Okay. So, this is this, then you need a protocol, at least one protocol between the control plane and the packet forwarding that we started out with OpenFlow, now it has evolved, there are many other ways you can do that, and then there is this global network view and open interfaces. So, literally now people are projecting software defined networking is whatever, depending on which report you look at, 150 billion to couple of $100 billion industry, and the idea is as simple as this, right? I mean, I am sure everybody understands it, there is no rocket science here. Separate the control plane, at the control plane create the global network view, write control programs, anybody can write those control programs, go and program forwarding. That is all SDN is in one slide, and you understand hopefully the rationale for it. Okay. So, if you could do that, what is the benefit? You bring openness and programmability, you accelerate new revenue generating services, you can help reduce capex and opex. The way you reduce capex and opex is now that forwarding device is much simpler, and it can be primarily built with merchant silicon and white boxes. You do not have to get those big vertically integrated boxes, and because you can control your network more easily, your opex operational expenses go down. And most importantly, the thing that is most important is the control in the sense of how the network behaves is now with the person who operates the network and pays for the network rather than somebody who is selling you the box. Okay, let me take a break and see whether I am communicating any question. I have a lot of material, I do not have to go through it all, but if I can communicate just these few basic ideas, that is important. So, I know there are a lot of students, so any questions or comments? Am I making sense so far? Yeah, please.
What's the motivation for Cisco or Juniper to do this? I understand what the motivation is for everyone else to have this, but if it's working, why change it?
But it is not working, right? The current thing is not working, and what is their motivation? Actually, they have no motivation, right? The only reason they are coming along because they do not have a choice. Their biggest customers are saying this is how they want to operate their network, and because the biggest customers are saying this is what they want to do this, they are coming along. Okay, but otherwise, yes, it is kind of business model wise, it threatens the current business model.
How do you make a decentralized operating system?
Sorry?
On your 2 slides ago, you had OS and a big red bar on top. How does that work? How do you have an operating system that goes between devices that are very far from each other?
Okay, very good question. So, yes, so you are 100% right that building of that what is called the network operating system, oh I have an animation here, is one of the hardest thing, and I will, so, but the thing is, so here is the thing, right, if you build it once, then you do not have to keep inventing the distributed system stuff. When you have a distributed control plane, every time you invented a new feature or every time you invented something, you had to solve the distributed systems problem. Now you solve that problem once, and then everybody benefit from it. So, I think I should go back, right. So, here what is being shown, once you build this right, then the guy who is writing these control programs does not have to worry about distributed systems at all, right, because to him or her, you are just working on this global network view, you do mobility management on this view, this guy takes it, the operating system, and makes sure it can go and program these devices properly. And yeah, so this is, I will talk about it, that we have built one of these in open source, we have built many of these, and other people are building that in open source and closed source as well. Okay.
I'm not a computer engineer myself, but making the network OS universal, would it maybe make it more vulnerable for any attacks?
Oh, excellent question, right. So, yes, so the thing is that if maybe what you said is that if this operating system gets compromised, then you are maybe compromising the network as a whole. It is true. On the other hand, the benefit is that if you can secure that, then you have secured the entire network. Today what is happening is, as I said, there are a million lines of code that go into routers, and every time we are adding it, it is very, very difficult to know whether that code is secured or not. And then when you have code coming from many vendors, it becomes even harder to do that. So if you can secure that one thing, then you can secure the network. But if you break in, then yeah, there is a major vulnerability there.
Off of what she was saying, so, since it's all open, you're going to find these problems very quickly, you'll solve them, but who's going to patch them, and is the network vulnerable because people haven't patched them?
Yes, I mean, if there are vulnerabilities and you don't patch them, then the network is vulnerable. I mean, that is obviously true. But yes, as you correct, I mean, you yourself answer the question. If you are doing it in open source, right, there are many people that are looking at it, and then they have an opportunity to fix, and whoever is deploying the network, it's not, so always remember, open source does not mean free. So open source is, somebody is still taking a responsibility to deliver that open source software and making sure it is working and it is fixed and all of that. So that particular, there is a vendor or somebody that is responsible for it, and that will do that.
They won't give you the patch, who will deploy it, and how is the network compromised if different people won't deploy it, right? But if we're both part of the network, and you deploy it back home? Oh, yeah, sure, no problem. So what I'm saying is, say we're two parts of the network, and you patch your side, will the rest of the network be vulnerable?
Yeah, I mean, I think it is true, right, that if you don't patch the part of the network that you own and you are operating with something like this, but that is always the case, right?
Yeah.
Everybody will have to patch to secure that part of the network. Okay, so okay, last question, and then I should move on to the, okay, go ahead.
Are you saying that people's personal modems and routers will handle other people's packets of information, even if those packets aren't meant for those modems and routers to make things more efficient? Is that what this is?
I didn't understand the question. I mean, if you look at this, right, so this is, if I am, say, AT&T, I have a piece of access network that I'm operating with this. These are all my network, and I have my own network operating system. I mean, that I might have gotten from a vendor or from open source, and I'm operating it, and so I'm responsible for my boxes and the operating system that is managing it, and the application, right? Okay, let me continue if you, okay. So I think there is this quote that was very interesting for a few years ago. This is John Donovan talking at Open Networking Summit in 2014. At the time, he was the CTO and executive VP. Now he is the CEO of AT&T Communication. And when somebody asked him from the audience, why SDN and why SDN now? And this was a very nice answer in terms of, because there is no army that can hold back an economic principle whose time has come. So this is all kind of driven by the economics of what happened. Okay, so I think so, again, in very quickly, how is SDN being realized? Okay, so the way it is realized is, this is what is in networking industry we call disaggregation. I heard it's a bad word, or it's not a valid word. Charlie yesterday told me that, but the whole networking industry is using it, and I think, so what that disaggregation means is that box is getting kind of horizontalized or disaggregated into a very simple box that is built with merchant silicon, and that is like a white box that you can buy it from Taiwan or whatever as the ODM manufacturer. There is a lot of open source, and then you can write many control applications on top of it, and they can be closed, open, whatever you choose. But all the bottom half of it is more or less open source, and it is done. And so here is how the industry looks like, and this slide is maybe a couple of years old, maybe now there are more things. So if you look at it, there is a proliferation now of merchant silicon, white boxes, open source, in order for us to build this software stack and build networks like this. So what I'm showing is these are the silicon vendors. When it comes to software on these boxes, there are all these things from Facebook and Google. The network operating system, there are at least 2 network operating systems that are now open source and used widely. Open Daylight is done by the community. ONOS is what Open Networking Foundation does, and the community. Then there are all this control and orchestration, and there are many, many VNFs and control applications that the community has developed. So you can see this is all happening and coming together. The interesting thing is that And this is not only in one part of the network. Now this so-called SDN, disaggregation, open source is across the networking industry. People are applying that in data center and inter-data center. In fact, if you look at all the big cloud providers, Google, Microsoft, Amazon, Facebook, they already practice software-defined networking for building their data centers, inter-data. So the network they build, it is all based on now SDN. Nobody is buying those vertically integrated boxes for their network. When they connect with the public internet, there they may be still buying those, but for their own, this has already made the transformation. In rest of the internet part of the infrastructure, this is happening, but they are the slower adopter in this space, and I will tell you about what we are doing to help in that space. I think just so that I can, for the sake of completeness, I wanted to tell you these are some of the things we did at Stanford during, say, 2007 to 2012 in Stanford and Berkeley, and of course, a list of partners. So you can see we built number of specification, open flow specification, we built reference switches, net FPGA-based, software-based, Broadcom chip-based. We built multiple network operating system as research operating system that went, and then we deployed it in our own network. So Stanford's own network was using SDN inside the School of Engineering, multiple buildings. We deployed this in many universities thanks to the Genie program of National Science Foundation. And then until 2012, there were 68 countries where SDN was being used in research context, not in production, in the research context. Until then, we used to keep track of it. And then you can see we did a number of demonstrations and all of that. Okay, so this is the work we did at Stanford during those years. And then this was the time when Google became a big champion of SDN, and they started to adopt SDN for their own network. Number of other industry network operators started to adopt SDN. And so that is when we started this organization that we call Open Networking Foundation. Because then we realized that SDN has long legs, and SDN can be important for the industry. So we wanted to start an organization where we can promote SDN, but not only promote SDN, build open source platforms that are industry strength, that industry can use and build on. And what you see here is these are the network operators that are our partners. They give significant funding and people and use cases in the trial. Some of the vendors are participating. I mean, Cisco and Juniper used to be part of it. I mean, Juniper is still. Cisco used to be, just recently they decided they don't want to continue for whatever reason they chose. And then if you look at it, this is all driven by network operators, some of the largest network operators who are wanting to bring about this change, and that is what they are driving. And then we, of course, have other operators, other things. It's an ecosystem of something like 160 companies or more that are part of this ecosystem. And even at Open Networking Foundation, in next whatever 20 minutes, I'm going to tell you a lot about what we're doing at Open Networking Foundation. So remember, when I say we, there are 35 full-time engineers that work at ONF. Then there are another 30 or so people contributed by our partners. And then there is, because in open source, there is a whole community. So when I'm saying we did this, we did that, remember, I'm talking on behalf of this whole community. Okay? It's not just me and few people. This is on the community side. Okay. So I'm going to give you now specifics of where we are applying software-defined networking, disaggregation, and open source. And that is actually what we call the new edge. And that is leveraging SDN, disaggregation, and open source. So I think, if nothing else, if you want to find out where networking is going and why it is very exciting and something great is going to happen over the next 10 years, please write down these URLs or Google them and listen to these talks. I think they are very inspiring in terms of what they are saying. So look at the headings. It's invoking or whatever, right? So that the edge will eat the cloud. You know, cloud is a big deal. Last 10 years, everything is about cloud. And now people are projecting that the edge is going to be even bigger than cloud for next 10 years. And I will briefly talk about that. And then there is Peter Levine. He is a venture capitalist at Andreessen and Horowitz, one of the top tier venture firms. And he's a return to the edge and the end of the cloud computing. It's not end of the cloud computing in my opinion, but he's trying to be controversial. But still, nevertheless, if you listen to his talk, what you will realize is there is another big transformation that is coming, and that is at the edge of the network. And if you are interested in networking, if you are interested in general, web and all of that, you have great opportunities ahead, okay, as grad students or undergrad. So let me briefly tell you what do we mean by edge, and then tell you the work we are doing in this space. So the edge is, if you look at what is going on in the industry today, we are building what is called a multi-tier cloud. These are the cloud that is built by Amazon and Google. These are the so-called public cloud. Then there are AT&Ts of the world and Comcast of the world that are building what they call telco cloud. And then this new thing that is emerging is edge cloud. And everybody is wanting to build this edge cloud, and I will tell you why in just a minute. It will connect to wireline as well as wireless, and then it will connect to users. And the other part that is important is devices. I think the devices part is even more important than users, because I'm sure you're hearing about Internet of Things, self-driving cars, drones, all of these things that are AR, VR, all those things. So through that you are going to connect through wireline or wireless. You will go into an edge cloud, and then rest of it. Now, what is being talked about is that edge processing is going to become more and more important. Because if you are going to have all these devices, autonomous devices or Internet of Things that are connecting into the network, and you are creating these applications, then they have to have processing at the edge, because they cannot tolerate the latency of going all the way into the public cloud and coming back. So people's expectations are that the latency requirements will be less than 100 milliseconds for some of this, and in some cases they are talking about even tens of milliseconds. And so if you want to do that, you will end up doing a lot of processing at the edge of the network. Okay? And there are many other reasons why that is the case. So that is why there is all this excitement for the edge. And so if you again ask the question based on everything I said before, that how would you want to build this edge? What is the functionality and what is the approach? So functionality is, you want that edge to be a service delivery platform. What that means is, connectivity doesn't really bring you money. If you talk to anybody, AT&T, Verizon, any one of them, connectivity by itself is the minimum thing that you can offer. What you want to create is the platform on which you can create interesting services. And when you build those services, that is how you can monetize it, that is how you can get revenue. So that is why it needs to be a service delivery platform. There are many different configurations, what you deploy in a central office, what you deploy on a cell tower, what you may deploy in enterprise edge. They may be different sizes, so you want to make sure you are supporting many different configurations. Plug in different access devices and technologies. You may have wireline, you may connect GPON or PON networks, these are passive optical networks. You may connect 4G, you may connect 5G, so you need to plug in different access technologies. You want programmable control and monitoring, so you want that SDN, and then you want economics of a data center that is same. You want to build it with merchant silicon, white boxes, and open source. That is how you want to build that edge. You don't want to build it using the old paradigm that we have used in networking. And if you're going to do all of this, you need that zero touch and all of that. But more importantly, again, this is how you want to build it, and you want future proof, because hard to predict services and proprietary component. So this is kind of an analogy that again John Donovan from AT&T uses, that it's not that you don't want proprietary stuff. There will be proprietary stuff in your infrastructure and your edge, but think of that proprietary stuff more as a Tabasco sauce that you use sparingly and only to get some good taste, but everything else should be using the other kind of economics. Okay, so I think this slide is again from architecture point of view very important. So once you get this, then rest of it we can go through very quickly. So what is being shown is, this is your enterprise, this may be home, and this may be your 5G thing, and you are connecting into the edge of the network or the edge cloud. right? I mean, these are the three different ways you may connect into the edge cloud. Now, as I mentioned that you may have different types of access devices. You may have wired, you may have mobile 4G, 5G kinds of access. And then you are connecting into the backbone, and typically you connect to backbone through some optical ROADM or that kind of thing. Because you want to run software and because you want to run services, you want a set of servers on which you can run software and services. And then because you have all of this, you need some way to interconnect everything, right? Because you have, if you're in a large thing, you will need a network fabric or internet connectivity fabric that will interconnect all of this and provide the network connectivity inside the edge itself. And then because you're trying to build services, you need some kind of a software stack that essentially creates what you can think of as a service delivery platform, and then you will create many, many services on top of it. Some closed, open, some network specific, some user specific, and all of that. And that is what you would want to do. And finally, because you will be deploying this everywhere, you don't want to send a lot of people, you don't want to maintain it, so you want to make it what is called zero touch. That is, you just plug it in, power it on, and it configures, or you can remotely configure it and boots, and that is. And it may sound far-fetched, but today if you look at how Amazon or Google deploy their data center, they are growing so fast, the racks keep showing up in data centers. And the technician just goes, plugs it in, does some basic wiring, and everything else gets configured more or less in an automated fashion. And you want to bring the same technology, same paradigm into the edge of the network as well. Okay? So is this picture clear? Because this is just basic. And then what I'm going to show you is that how we have built this using all the open source building blocks and white boxes. But is this makes sense, right? This is how it should look like. Okay, so let me now tell you how we have built it. So when it comes to the access devices, Ethernet is simple. I mean, Ethernet white boxes are available anywhere you go and you can get it. But what happens is when you think about these OLTs, OLT stands for optical line termination, and this is for the terminating the passive optical network. So if any one of your subscribers of AT&T or Verizon's gigabit or whatever, anywhere close to gigabit connectivity, that comes on the PON, and then it gets terminated in something called OLT. And these OLT boxes are again this big vertically integrated boxes, and what we are trying to do is to disaggregate them, and that's what we have done. We'll talk about that. And similarly then, if you're connecting over 4G or 5G, then these are again the base station. If you've seen the base station, they're again closed, vertically integrated, comes from Ericsson, Nokia, and Huawei. And again, we want to disaggregate them. We want to, and I will show you how we have done that. We use OCP server. These are commodity servers. We use ROADM or disaggregated ROADM. And then we have built our own switching fabric, like what is used inside a data center. It's a leaf spine fabric, SDN-enabled white boxes. ONOS is the network operating system that we use, and then fabric applications. Then we have built a software stack. We use OpenStack, Docker, Kubernetes, and then we have built a couple of our own operating systems that we call ONOS and XOS that does all the service orchestration and service composition. And then on top of that, we have built more than 25 services for these domains. Okay? So this is kind of the high-level picture. Now I want to walk you through some of the details. But any questions I can answer before I go? Now I'm going to take you a little bit deep into the kinds of things we have built.
So one thing I don't understand, how do you envision this edge cloud to be architected? Every single edge device, the computational power will not be sufficient. You need to interconnect them. If you interconnect them, the latency will be significant, but the latency is what you wanted to solve in the first place. So how do we envision the architecture and the interconnection to get to significant computational power of the edge cloud?
So maybe I'm not, so I guess, okay, so you may have a device in your home, it connects into XGS PON, it comes into the switching fabric, you may be running the application on the server and then you return it back. And the server, depending on the types of applications you're running, you can deploy how many server, however powerful servers you want, or you can use GPUs. So we have used some of the GPUs as servers to do that computation. And then this turnaround time, we can do in 10 milliseconds or so.
So you envision some servers close to the edge.
Oh, this is all part of the edge cloud, right? Oops. What's happening? Oh, it's not. Oh, gone. So, yes, I think these servers that I'm showing, these servers are at the edge. This entire thing is at the edge. So this is the edge cloud. Okay. Anything else I can answer about this big picture, and then I'm just going to take you through details. And if you now want to take a nap, you are welcome to, because now I'm just going to take you through the details. But this is the big picture that we have built, and other people are building as well. It's not just us, others are building that as well. But this is kind of the edge cloud, and now there is a lot of excitement about deploying this edge cloud and all of that. Okay, so let me see. And then of course the zero touch, and we have built it with merchant silicon and white boxes in open source. Okay, so I think here is the kind of the software stack, just so that you know. So this is again the home, OLT, you are coming over the PON network. We have created a software called Volta that creates a hardware abstraction on top of different types of OLT devices. Then we have the network SDN operating system. Then you can have many applications that control that OLT and this particular thing. Then if you are coming over a RAN, either 4G RAN or 5G, again we use the RAN controller which is based on ONOS. You can have control applications here for the radio access network. Then the fabric, again as I mentioned, this is the leaf spine fabric. ONOS is the network operating system for that, and these are the fabric applications. And these are the servers that you were talking about, and here you can have GPUs or whatever kind of acceleration. Here we use OpenStack, Docker or Kubernetes for virtualization. You can have all these applications. And then we have built another open source platform called XOS that stands for Everything as a Service Operating System. So as you create many, many services, that XOS is responsible for managing those services, orchestrating those services, and composing those services, and I'll give you an example in just a minute. So that is what the software stack for that edge cloud looks like. And as I said, it's all built in open source, it's available, you can download, anybody can download. Okay? So this is, I think earlier there was a question that how can you build a distributed network operating system, and so this is what we have built, other people have built thing. So what you see here is this is a distributed network operating system, this is your network, you can have multiple instances, so you can horizontally scale it. You can run it on 3 servers, you can run it on 7 servers, you can run it on 9 servers, and you can horizontally scale that. Okay, and then southbound you can, you know, whatever protocol you choose, and then you have the distributed core, the application intent framework, and then, you know, these are the kinds of performance that we are able to demonstrate. So over 3 million flows, this is the kind of latencies that we are demonstrating, high availability and all of that. Okay? So this is kind of how we have built, and this is definitely one of the best distributed network operating system that is out there today in open source. Okay. Then when it comes to the fabric, as I mentioned, it is again built as a leaf spine fabric. Again, this is a very standard architecture. Almost everybody is using it to build data centers. I mean, from Google to Facebook to Amazon, everybody uses this. We have done it all in open source and with white boxes. Okay. And so again, this is the leaf spine fabric. You use ONOS as the SDN operating system, and those are all the control applications I'm talking about. To control the fabric and the connectivity inside the edge cloud. And you know, this is detail that may not matter. And the interesting thing is that Comcast is taking both that fabric and ONOS into production network. They just turned on Seattle, I guess yesterday or today. And so they have plans to deploy this in all their access side in their network. So this is going into real production networks of real service providers, and you can see how the industry is really changing and transforming and adopting these kinds of solutions. Okay. Now when it comes to that OLT, as I said, that OLT is a big box today. What we have done, again with the help of AT&T and Broadcom and others, now we have turned that box into like a typical pizza box. Okay. So that pizza box, like why you buy server or something, and again this is coming from EdgeCore as a white box, merchant silicon from Broadcom, just a simple box, and all the software is running on top of that software stack. So all the control and everything for that whole access network for your GPON is running there, and the box is relatively simple. And so yes, okay, good, I have a slide. So this is how the box looks like, and we have reduced that to the box that looks like this, just a pizza box, a software abstraction, ONOS as the network operating system, and then control. I mean, what I showed you earlier in abstract, this is exactly what we have implemented, and we do this, and this is continuing with now we are connecting many different types of OLT devices, and including XGS-PON, which is the 10 gigabit, which is just coming out now, and AT&T, and yeah, and this is kind of the service graph, because you don't want to provide only connectivity. Nobody is interested in providing only connectivity. You want to provide services, and you want to provide those services as software. So what is being shown here is that you can create this kind of a software, I mean service graph. It is trying to tell you that everything, these are control applications, these are other applications that are managing the access network. They are all constructed as services. You can construct a service graph for a particular consumer or a particular thing, and the end customer like Comcast or AT&T is able to modify this depending on what they want to do with their customers, and they can do it. They don't have to depend on a vendor. They don't have to depend on anyone else. They can do this. And so this, all these network operators are trialing it, and hopefully they will take it into production in 2019. But look at it, AT&T, Deutsche Telekom, Google Fiber, Telefonica, Turk Telecom. So these are serious players who are now saying, we don't want to build the networks we used to do for 40 years. We want to build this with different value proposition and different approach, and they are all doing that. Mobile 5G network, if you'll again look at LTE network, they're built with boxes like this, right? Big vertically integrated closed boxes. And again, what we are doing now is, again, at the heart of it, same building blocks, same merchant silicon, white boxes, open source, that software stack I'm talking about. And now what we are doing is both on the packet core side, we are disaggregating, virtualizing, and open sourcing, and the same thing we are doing on the radio access side. We are disaggregating, virtualizing, and open sourcing all of this in preparation for the 5G. Okay, and again for 5G, when you want to provide services, more than just connectivity, you can create different service graphs, and those service graphs can be customized for different customers, different services. You can do slicing and provide different service graph for different slicing, and that is what we have demonstrated. Okay, I have this slide. I'm sorry, this is a bit marketing slide, but this is what we demonstrated, the different capabilities recently as far as MCOD is concerned. So let me wrap it up. I think I should be done. Anyway, so these are a little bit too much marketing here. But the interesting thing is, even here, this is kind of the 5G platform for enabling 5G, and China Unicom as well as Turk Telecom are taking it into trial later this year. So again, an indication that these providers are quite serious about doing this. Here is the list of different services that we have built, and you can see there are some serious ones. So if you are familiar with mobile network, all the EPC and RAN, now we are doing this in open source with software that you can run on white boxes. Again, this is not ready for production, so I don't want to give you the wrong impression that this is ready for prime time and you can deploy that in production, but it is demonstrating that this is possible, right? And I can tell you that last 5 years, so many times the vendors, the incumbent vendors have come and told us this is impossible, you can't do this, you're crazy to be doing this. And we have done one demonstration after another demonstration after another to say that, yeah, we can do this, come and check it out. Right? It does not production ready, it may not have the scale, but it is doable. And once you demonstrate that it is doable, even as a proof of concept, now the industry is convinced that even you can take this approach and create a production quality solution and thing as well. So that is what is happening now. Oh, I think, so here are the different network operators that are using COD pods in their labs. Some of them are taking it to trials, and Comcast just took it into production, for example, so that is a big deal. Here are the different companies that build card pods and offer you. If you want one, you can build it yourself using open source and all of that. So again, just to conclude, what we are saying is that card building block is what we think of it as the core platform for the new edge, right? You can run many services, service graphs, and I'm only showing 2, but you can have many. There are multi-tenancy. You can run per customer, group of customers. You can have virtual providers, and you can do all of that. And then you can have many different configurations. You can have it in half rack. You can do a full rack. You can have multiple racks, and you can choose the type and number of network interface you want. You can pick servers. You can pick services. You can configure all of that. And so it is becoming kind of the platform of choice for the edge. And this all done in the way I described. And not surprisingly, there are many now analyst reports that are coming out that are very encouraging. They are already declaring, I mean, they are, in my opinion, they're declaring its success too early. We still have long ways to go, but they're already claiming that, you know, whatever you say, 70% operators will do this and 40% of the traffic will run on this. So it is premature. I'm flattered by this in some level, but it is, just to be honest and candid, this is premature. We still have ways to go. But it is interesting that people think that the network can change and it can go this route. Okay, I think I have made all these points, so let me not think, but the idea is, you know, platform for the new edge. Whether you believe in card or not, that's a secondary thing, but go and take a look at what is happening at the edge of the network and what that is going to mean, because it's really, personally, I think it's going to be very exciting next 5 to 10 years, what is going to happen at the edge of the network with all these applications that are coming along. And that will be very good. Okay, I think I'm done. So do we have time for a few more questions, or are we running out of time? No.
Thank you for the talk. You've mentioned several times that you're building open source software. But there's a big difference between open source and patent free. How are you certain that you're not infringing on patents that companies own, and they're not going to show up 10 years later and sue everybody in sight for violating their patents?
Excellent question, very good, and sometimes I do worry about it, and there are people. So the only way I can be a little certain is that if you look at our ecosystem, in terms of the companies that are participating and part of our ecosystem, there are, you know, a lot of big names and so on now, and they are participating and contributing. But yeah, there is that risk is there, and there, I mean, we work very closely with Linux Foundation, and Linux Foundation has to deal with that on multiple occasions like that. So there are precedents of how to cope with that. But your question is very valid, and you know, I cannot predict what's going to happen 2 years out if somebody is going to come and sue somebody saying, hey, you are infringing on my patent. So possible, I mean, that's a real risk.
Thanks for the talk. The business case for SDN in the edge, and especially in the data center, has been obvious for a number of years because it's basically enhanced Ethernet switching that's easy to control. Where do we stand on incorporation of SDN into the Tier 1 backbones?
Backbones are, so if you look at, you can divide backbone into 2 parts, the optical transport and then the real routers, the core routers. So I think the core routers is going to be the last one that people will change to the SDN way of doing things for multiple reasons. One is that at least what we hear from whatever AT&T and others is that backbone is relatively static. You add capacity to it, but you are not, it's not changing as much. And if you look at, for example, you know, you are very familiar with AT&T and so on, 80% of their CapEx and OpEx is tied to the edge. right? So when you look at the AT&T network, so I give another talk where my first slide is, it is the central office stupid, because that was the realization I had by working closely with AT&T. They kept saying that if you really want to help us reinvent the access network and help us reinvent the central offices, right? Because that is where the 80% capex is tied to. So backbone is not something that they are very keen to change in the short term, and that is also, if something goes wrong in backbone, there is a, it impacts a lot more customers. But if you look at the optical transport, there people are adopting SDN faster. Because it is easier, and as they are building more capacity, they are using SDN. So for example, I didn't talk about another project we are doing called ODTN, that stands for Open Disaggregated Transport, and their entity Comcast, there are at least 4 or 5 providers that are wanting to take it into trial. Whether they'll deploy it, the time will tell, but that's what's happening.
Do you envision that, or can you envision that SVN will ever go beyond, the control of a single entity, a single provider, which would take some serious coordination, to have SVN controlled by multiple entities?
So if I understood your question, you're saying, will SDN go beyond one operator's network? So very good question. So I think it is already, so if you look at, I don't know, you may not know, Google has a project called Espresso that they already deployed. So what Google is doing right now is that when they peer with anyone else, that peering point is SDN based. And they have a centralized thing, and they peer with this. So I think you can imagine that Google's peering point is already SDN based. If the next guy that is they are peering with, if they also adopt SDN based peering, then you would have software defined based peering, and BGP will play lesser and lesser role. But we are not there yet. There are some ways to go. But I'm just telling you that if you look at the Espresso project from Google, and that is already deployed, it's not just a project, it's already deployed, and they are doing all their external peering with Espresso. Okay, are we done? Okay, thank you.